I invite Professor Asad U. Khan, sir, for expert talk. Over to you, sir.
Thank you very much for inviting and very elaborated introduction. And I must thanks to the dignitaries from the Integral University, especially the Vice Chancellor, Professor Javed Masara Saab, who has been my teacher. And I'm delighted to share that I think he is the first mentor and the first teacher who teach me how to do the microbiology. And from there, I developed interest in microbiology, and later on, I have developed my own field of multi-drug resistance. So thank you very much, sir, and all the dignitaries. Also, thanks to the Chancellor of the university, who has facilitated this program, and in collaboration with my personal project of the DBT on antimicrobial resistance. I think a comprehensive, detailed talk on the crisp talk on the AMR has already been done. Can we share some our presentation? Well, so today, since it is an AMR week, awareness week, so I would like to share some of my experience last couple of years, more than a decade. So I'll be talking on core AMR in general and what is going on in my own lab in terms of like cope up with the situation. So currently my main area of research, which I'm focusing on around the AMR, antimicrobial resistance, the mechanism of resistance, the structure inside biofilms and resistant markers and mutants. And the approaches which I'm using is genomics, proteomics, bioinformatics, gene editing through CRISPR-Cas system. So through all these approaches, I'm trying to solve the problem of antimicrobial resistance. The therapeutic approaches which I'm also looking into is inhibitors designing to inhibit the culprit enzymes which are causing our main reasons of the AMR, and of course PDT-based technology. Some of the glimpse of the research is going on AMR for last couple of years in my lab is well published and acceptable. And some of the part we already processed for the patent in terms of like inhibitors, and some technology we developed like PDT. Here we have just tried to map some of the very important mutants, which are future mutants. Like we call them as a laboratory mutants. And having the scale of these mutants in a variants, it would be very, very difficult to control the situation. That's how we have tested. And we have generated at least 12 laboratory mutants through site-directed mutagenesis, and we well characterize them in the structurally and functionally using the all kinetic parameters and the hydrolytic nature of these enzymes altogether with these antibiotics available as well as inhibitors we designed. So we are also trying to make a complex with a crystal, and we tried for more than a year to make a crystal structure of these complexes. And unfortunately, no crystal structure has yet been identified because of many troubleshooting, although we did a lot of troubleshooting, but unfortunately, we are not successful. So we modeled certain structures through bioinformatics, and we overlap these structures, and we identified some residues which are really involved in the drug resistance. So we are trying to map these residues and for the future drug designing purpose. In this study, we very well characterize we synthesize and we develop a CRISPR-Cas mechanism in our own lab. And this is the first time we identified the role of CRISPR-Cas in the biofilm inhibition using the whole structure of Cas RNA, DCas nucleases, designing our own lab through sgRNA specific for the specific genes involved in CRISPR. And that paper published in Frontier Immunology and Cellular Infection Microbiology. And I'm happy to share that these are the first paper ever. If you go to the PubMed, you find these are the first paper ever published on biofilms inhibition through CRISPR-Cas technology. So thanks to my student, she's in Chicago in a postdoc, Azna, who did all this work. In this domain of research area in my lab, I'm trying to develop some PDT technology, photodynamic therapy, and we developed certain animal model. We developed animal model through infectious infection through highly drug resistant strain in my own lab, and we treat them. And successfully, recently, I have not mentioned paper here. Recently, we published one paper in European Journal of Pharmaceutical Sciences and one in Scientific Report, and another is Photocomfort Biology B, where we have shown that how effective the laser technology is, you know, to avoid the antibiotics and to reduce the resistance. And it works very well, as very rightly Professor Javed Masara Saab, the Honorable Vice Chancellor, mentioned that in his speech, keynote address, that the overuse of antibiotics is really one of the major reasons of the drug resistance. So we have another technology which we call the complementary technology, or the alternative technology, where we can, without using antibiotic, we treat the, and we have already proved it through even animal model. This is another domain of my research area where I'm interested in the caries research. And my interest in the caries research is because when we learned in microbiology, while I was teaching in a class, that over 600 bacterial population is present in our oral cavity, and that will lead to the caries and a lot of oral problems, which may lead to the systemic infection, even myocardic infection, even even several heart diseases may also link with the oral hygienes and oral infections. And that's how we develop interest, and we develop a caries model in vivo model as well as in vitro models, and we proved through certain molecules, and through nanoparticles base coupling of certain molecules, that to treat the caries altogether. And we have proved that yes, we can completely treat the caries. This is the paper we published in by Fowlings and AMB, pathogenesis and so on, where we have shown clearly that yes, and BBRC came recently 19, where we have shown the caries infection completely cured without using any antibiotic. Now, this is designing inhibitors against targets we are focusing on as an alternative, because no drugs is available, as mentioned earlier in keynote address of Professor Javad Masarat, that we have to wait for death. I mean, in case if no drug is available, even last resort of a drug like colistin and imipenem, meropenem, atropinem, doropenem are failed more than 30% of patient. Can you please, hello? I'm sorry, I'm just give me minutes. I'm receiving a call from Vice Chancellor's office to send one message. Hello. Sorry. Okay. So the greatest challenge for AMR is because antimicrobial resistance is the ability of microorganisms to stop the action of antimicrobials. So to date, we don't have any antibiotics available to cause to kill the bacteria. And this is a gentleman, one of the famous person, Ramanujan, who was basically died because of infection, tuberculosis in 1919. And this man was saved because of the use of penicillin in 1941, Albert Alexander. But the man behind the discovery of antibiotics already told earlier, decades ago, that the use and misuse of an overuse may lead to a problem. That's what we are facing today. Now, the discovery of the superbug is a great challenge for physicians, already published in several papers. And this is the paper in 2021, challenge of superbug by a group, famous group in New England Journal of Medicine, on the top in medicine journal, clearly mentioned that how difficult it is to control infection now because of the discovery of these superbugs. Now, why resistance is a concern? As we all know, resistance organisms lead to the treatment failure, increased morbidity, mortality, burden on the healthcare's economy burden. Resistant bacteria may spread across the community, and it may threaten failures to current antibiotics in use and may return to the prehistoric era, just like before 1940s. WHO has already declared one of the top priority research area, having infection in even common bacteria like Klebsiella pneumoniae and E. coli, causing several diseases, deadly diseases, and deadly infections. And I met Poonam Khetripal, who's the regional director of the WHO in Southeast Asia, who was in his speech told that resistance is a priority research area and has to be taken care uh, seriously, even sensibly. Now, here I would like to share you some of the very fascinating structures. Looks like a very beautiful and fascinating artistic structure, but these are real culprit, which has to be killed, which has to be degraded, and which has to be wiped off from the whole scene of the bacterial population. That's we call different classes of the beta-lactamases, A, B, C, D. I've tried to cover all these four, and my lab is focusing on a broad spectrum inhibitor designing against all these four, and with that too of non-beta-lactam type that should not be reverted back. This is the basic mechanism behind, as we all know. Can you please give me 1 minute time? Just 1 minute. Now, the discovery of NDM1 as one of the more notorious carbapinamases is 2009, already mentioned in a keynote address. I'm not going are severe than NDM1 in terms of like action against the hydrolytic activity of the drug. So that shows how evolving trend of the drug resistance may lead to the problem in the drug resistance. The experts, as per the experts in WHO and CDC, by 2050, it increases the antimicrobial resistance to the level that it may cause to 300 million deaths. And it may impact on the total GDP loss of 100.2 trillion US dollar. And by 2050, 10 million deaths will take place every year, which costs around 66 trillion pound. That's too much. Keeping that in view, my lab is focusing to save lives of humanity and trying to our effort towards the AMR in order to control such kind of disorders, such kind of challenges. If you compare the ailments, AMR compared to others, you find the AMR is number one. It's on top in terms of like taking lives of humanity every year by 2050. That's a serious concern. Should be serious concern for all peoples. Now, the paper came. This is a very serious issue now, published by a group in UK, NEJM, one of the top journal in 2019, where they are based on this paper. What we conclude that all pharma companies stop making drug. I mean, that's a serious problem. The high priority is not antibiotic. The priority is different for various reasons. I'm not going to discuss at this forum. But the reason is same, that antibiotics, the day antibiotics are launched into the market, maybe in a year or so, the resistance develop because of use and misuse of antibiotic. Well, this slide is a little scary slides, but I'm not going to scare you, but just to make sure that experts says that not 2050, even before, as per WHO 2050, it may lead to the 10 million people die every year, which is just like a plague, just like a pandemic. So we have just passing through the pandemic, ill effects of a serious pandemic of COVID-19, but I think it's not far. It's not far that we may have another pandemic in a year, next down the decade or so, even before 2050. I can predict as 21st century pandemic because of the AMR problem. Because more than 90% of the human pathogens which are around us, our hands, our skin, all together, whole biome is basically made of these pathogens, right? Are getting resistance, develop resistance, and then cause infection under certain immunocompromised conditions. So you being healthy may not be at risk, but elderly people's are neonates. My lab is focusing for last 10 years at least on neonatal intensive care unit infections. And uh, need not to mention, but we have tried to improve the death of neonates for last 10 years tremendously. And our research and our testing system improved a lot. One of the Professor Manazir, who's a leading pediatrician in AMU, JNMC, who's in charge of an ICU, is in collaborating with me, providing the sample and providing the history and data of the neonates. And we are working for last several years, and we published together good papers. Well, today I'll just give you another hint of the structure of a carbapenem, which are very common, and this is main susceptible area where to be degraded by the thousands of different varieties of the different variants of enzymes class A, B, C, D, we call carbapenemases. So we have to protect this region, only this region, from this, and that's how you can save your drugs and make the drug effective. But the reason why carbapenemase is having a difficulty in tackling and handling the situation. So, the reason is very simple. We call triple difficulties. Difficulty to detect, very difficult to detect, right? Even beta-lactamases can be detected, but carbapenemases are rather difficult to detect. People are trying to develop sensors based on the blood test. But it's hardly difficult to identify a specific marker. If you have NDM, it's difficult to find OXA. If you have OXA, it's difficult to find M. If it is M, you are difficult to find WIMP, and so on and so forth. Difficulty of a treatment owing to the multi-drug resistant characters with a few drug remaining actives. So nothing is left. And difficulty to limit the transmission. And the spread is very common, very fast. So the most common carbapenemases so far we identified is Enterobacter cloacae, in NMCA, IM1, KPC, OXA48 is very common in subcontinents, even in India, although it was discovered in France 2004, and Andium in Sweden-based, Indian-based Sweden person in 2009, all creating a lot of havoc to the physicians and healthcare workers. The carbapenems in Enterobacteriaceae, which are, we call them as very common. So penicillin, cephalosporin, first and 2 generation. So this is all resistance goes like anything. See, all the drugs are fail because of the production of these. OXA, IM, WIM, NDM, CHES. Now, this paper came from Robert Bonomo's lab, who's one of our collaborators, and this is basically is one of the collaborators from my lab who's working on inhibitors and designing several molecules, mechanism-based inhibitors. So they worked on KPC to improve the activity of KPC. To reduce the activity of KPC by designing several inhibitors. And I'll not discuss the detail in papers, but I'll just go through the current scenario of our India and our country, and rather the whole globe, based on this background. There's a study on 10 Indian hospitals published in 2018. Though it is old data, but the collection of the data is taken now. Still 2018 onward, the researchers are working on the data collections, and it may take time to get the report, maybe next in 2021 or end 2022 mid. I will have another scenario, but this is, we call them a current scenario based on the report till 2018, both in the bloodstream infections and others. I'll just give you to some of the very important data that give you a clue that how difficult it is to now. So this is a situation, you can take a pictures. This is the common everywhere. So we are living in this area, causing one of the major issue of drug resistance, using unhygienic conditions and the full of niches of bacterial populations and other microorganisms. This is 2017 we published based on the earlier 2015 data, one of our own review articles, where we have shown the the spread of NDM. And recently we are working on the database again on NDM, and I've been involved in European Commission databases. Unfortunately, India has no complete resistome data. So one of my projects is working on whole resistome data of Indian on metagenomics, which will come out maybe in the next 2 years or 3 years, I hope, inshallah. But NDM, this database based on the available literature is available. So it's not the experimental data, it's the review articles, more on the published secondary work. And we found India and Bangladesh and subcontinent are the major reservoir of the production of the such bacterial population having the expressed NDM population. And in 2015, the discovery of the MCR1 gene. Now we have a variance of MCR1, 2, 3, and even 10 and 5.1, 5.2, and many more. Fortunately, in India, it's not much because of the reduced use of antibiotics in poultry compared to China and USA, where the tremendous use of antibiotics are being used. India is the least user to date, but in 2030, it is said that India will become a next highest among the countries using the antibiotics in the poultry farms and livestock. But this pose another major problem. This was published in Lancet 2015. The first report, and this is the problem occurring in Indian population also. Now, some of the data I'll share with you of the hospital data, where we have shown the kind of a common bacterial population involved in infection and drug resistance as well. So if you look this E. coli studying on more than 5,000, 3,000 to 4,000 tested isolates in different conditions, blood stain, urine, and oral. We found the drug resistance, in most of the cases you find more than 80% and 70% to 80%, more than 80% drug resistance was found against these bacteria with the antibiotics available. So that shows a really big problem and challenge for the physicians and healthcare workers, and of course, not good part for the patients as well, in both an ICU, IPD, and OPD. So this data is taken from 10 different hospitals of IPD. It's not my data. It's a data collected by CDC based on the multi-institutional study, but I'm using that CDC data here to show you. It's not my data. It's not my personal data. Now, Klebsiella species again showing, tested again. So this is just to show you the current scenario which is going on. There is more than 90% resistance against all these antibiotics. So in this scenario, how do you treat patients? At least 20 to 30 patients have to die, have to give their life because of the unavailability of the drug. You can't save it.